Okay, the concepts are joints. So we discussed about singular functions, group functions, we discussed about convergent functions, right? Various different functions. Now all the functions that we discussed until now, everything we played with only one table, right? We've learned applying those functions, having different filters, different scenarios, but everything was done with only single table. Now this is not a practical case where you'll be playing with only one table. There'll be a lot of other tables that you'll be playing with when you go to companies or your jobs. So all you have to do is, you'll have multiple tables and you have to join. When you have to combine multiple tables and then extract the data, we use the concepts joins. So whenever you have one or more tables, then you start applying joins. Is that clear? So there are two types of joins. I can say two categories of joins. So one is horizontal joins and one is a vertical join. What do we mean by that? Let me open up an Excel sheet. Let's say I have a column A and a column B. Now some data 1, 2, 3, 4, 5. Some data 3, 4, 5, 6, 7. Center. Alright, I have two columns. Sorry, I can say two tables. This is table 1, T1, table T2. Okay, I have two tables, table 1 and table T2, and in each table I have one column. Can everybody understand this? Okay, so I'll start applying joins to these two columns. I'm trying to make it easy to understand. So once we understand this, we can make some complex examples. But for now, we'll just get started with these two. So we have two tables and we have one column in each table. So if I say, I'm saying there are two types of joins, horizontal and vertical. What do you mean by horizontal? Right? Rows. Vertical are columns. So when I say join horizontally, I join the rows. How many rows do I have? 5 in table 1, 5 in table 2, right? These are joined on rows. That means, let me put it here. These are joined on rows. Does it make sense? I join the rows together. That is joining horizontally. So when I join something like this, I have table 1 data and table 2 data. When I join them on rows, this is what I'm doing. I'm increasing the number of rows when I apply a join, right? So when I apply a join, and if the rows are increased, then it becomes a horizontal join. I'm not done yet. I'm just explaining randomly what concept is. Alright, if I join it this way, it is a horizontal join. Other way, if I join the data like this, it becomes a vertical join. I'm joining columns together. Am I increasing number of rows?
No.
No. I'm increasing number of columns. That's called a vertical join. Alright? There are these two categories in which the joins are differentiated. So one is a horizontal join and one is a vertical join. So there are specific names for it. They do not call it vertical joins or horizontal joins when you go to or when you look at the books. So there are specific names for these. In horizontal joins, we have a concept called, or the type of joins that we discuss are set operators. And in vertical, what we call as traditional joins. All the joins that we discuss, inner join, outer join, whatever you've been hearing all these days, everything sits here. And these two concepts are very important for the interviews. You can expect a question for sure, questions for sure, not just question. So all you need to remember is whenever we apply set operators, we join data something similar to this. There are different variations. It's not this simple. There are different variations to it, but set operators joins them on rows, joins will joins them on columns. That's the basic principle behind this stuff. All right. So let's just start with set operators. Okay. So as part of set operators, the first set operator that we have, or let me come back a minute. Okay. There are two rules. So first of all, what we are discussing is set operators, right? So for the set operators, whenever we try to join two tables, table 1 and table 2, on a particular column, right? We join on a particular column. That's how we increase the number of rows. Agree? So when we do it, there are two rules that we need to always satisfy. I'll write the syntax before we discuss about the rules. So select star or select column 1 from table 1. This will give me one column data, right? From a table 1. So I'm going to pull up the select column 2 from table 2. Suppose these two are different queries. This will give me one data and this will give me another data. I'm trying to join these two data. The way syntax changes is, I'll put the set operator here. So everything is one single query. We have query 1, set operator, query 2. Okay, everything becomes a single query. So this one will give us one table data, this one will give us another table data, and in between we apply a set operators. Okay. Now, in order to apply set operators, there are two main rules. First rule, rules to apply set operators. 1. Number of columns in query 1. I'll call it query 1. Will that make sense? First one is query 1, second one is query 2. Number of columns in query 1 should always be equal to number of columns in query 2. What does this mean?
If there's 4 columns in the first table, there has to be 4 columns in the second column.
I'm not saying table 1, that's why specifically I'm calling it query 1.
Whatever data we are pulling up from the table, both should match. Should have an equal number.
So if I'm pulling column 1, column 2, column 3 from this table. For example.
Have the same data like
No. I'm talking about this rule.
same column.
So this one has 3 columns, this query. This one I'm pulling only 1 column. I cannot apply a join this way. I need to pull 3 columns even here. Only then I can create a join. Column 3, column 4. Now this column will be joining to this one will join to this, and this one will be joined to this.
The column name has to be the same or
No.
doesn't make a difference.
Whatever I'm telling, that is the only rule, no other rules. Just there should be number of columns that I'm having here should match with number of columns. Specifically saying number of columns, not what data we have. Not talking about it. The first rule that we have is the number of columns in query 1 should match with number of columns in query 2. That is the first rule. Okay? Next rule. Let's say if I have data type to be number here in column 1. Column 1's data type is number. If column 2's data type here in this one, okay. Now column 1's data type here is number, and let's say column 4's data type is varchar. If I merge them horizontally, what happens? Everything is a single column, right? Can a column has both varchar data type number and varchar? No, it cannot. It will throw an issue. Agree? So that is my second rule. So what is my second rule?
Same data type should match.
Columns should be of same data type. These are the only 2 rules that we need to apply in order to apply set operators. Now, let's say this is number. Okay, I just didn't want to change the syntax here. So let's say we have number here and number here. Can we join it happily? Fine, right? So this is the correct syntax. Now let's say, for example, column 1, the data that we have, I'm just having a comment here. Let's say this is employee number. Okay? Let's say this is salary. Does it merge?
Salary and employee number both have numeric.
This is what I'm saying, number and number. But the data here is salary and data here is column 1.
According to the rule, it will.
According to the rule, it will. SQL doesn't know what data they have. It just depends on these 2 rules. Are we equating number of columns here and here equally? Yes, we are. Data type? Yes. It doesn't matter what data that you have in there. It just has to satisfy those 2 rules. So it's your responsibility to make sure that you join it correctly. If you have employee number here, you have to always equate it to employee number. Otherwise, it doesn't make sense in making any joins. Is that clear? So you have to be very careful when you apply set operators, because if you satisfy these 2 rules, it can accept any columns, and that might mess up the data. So every time you merge columns using set operators, you have to be pretty careful. Is that clear? Now, there are 4 different types of set operators. First one is union, second one is union all, third one is intersect, and fourth one, the most important one for the QA, is minus.
So that one is not going to work because it's salary.
It will work,
It will work.
but the data will be wrong because employee number column has also salary data.
It doesn't matter if it's a primary key column or if the column, but here typically in a salary column you would have decimal places. Right? So
Mhm.
it will work, so the data type for employee number and this will not be the same.
Is that fine now? No decimal points. Don't worry about the data, I'm just explaining the concept here. You had a question, right? What was that?
Yeah, because I mean, it'll work as a join, but if the data is different, I mean,
That's what I'm saying. You have to be very careful when you join. Now, so each of these has a different functionality. There are four types of set operators. How do we replace them? If in this query, if we take this query, let's say we have same columns. I just remove the set operator here and replace this with union. That's how the query changes. The syntax changes. Okay? Now, what does union do?
It measures all the records from that.
So union, it merges all the records in both the columns. Horizontally. If it finds any duplicates in the data, it will merge them into one record. So union. So this function, what it does is it merges all the records from both the tables. So if you have 5 records in table 1, 5 records in table 2, it will merge everything together and make it 10 records. And in that 10 records, if it finds any duplicates, it will merge them into one record. Let's say in those 10 records you have one duplicate. It will merge them and make it one. At the end you'll have only 9 records. Make sense? So if we go back to the example, I have this one. Let's say I have a query here. Select A from T1 union select B from T2. What will be my data?
You get 7 records.
What is my data? Tell me what.
1, 2, 3, 4,
Column name is
5.
A. Tell me from here.
1, 2, 3, 4, 5, 6, 7.
It will merge the duplicates together. That's what we have. Is that clear? Questions here? If I do a union, it will merge them horizontally, that is on rows. Once I do that, all the common records that I have will be merged into a single record. That's what we have here. Is this concept clear?
so it can increase the number of rows in the process.
Yes.
If there is value different in that number, the value is different, we can merge together.
What is different?
Means there is only some, where example 1, 2, 3, 4 is there is different number. Means 5, 6, 7, 8, 9, 10 like this.
I have
we
it
can
here.
merge together. This is only number, it's a big digit number. Or
Whatever it is. Merges everything.
Okay, they both are together, not.
What is together?
No.
Hmm?
That both number is coming one.
That's what I'm saying, right? It comes as one column. That is the join that I'm doing. This is another. This is table 1, this is table 2. When I'm applying a set operator between these two columns, these two tables, it merges into one column. That is the join that I'm applying using set operators.
I think the question is that particular value and we needed a joint. For instance, what set is it like? Is it going to multiply? Is it going to add? Is it that's maybe.
But can you repeat that?
The question is when you are merging the two columns,
Uh-huh.
let's say the A and B, and then you have each, let's say the rows, that's how it goes, right? The row, we're going to have like the 1, 2, 3 until 7. So we'll try. I think I got the point because I thought it was a kind of some sort of operation within the rows, but it just heads up, make it more overall.
So your question is. You have some data like this. Can you merge? Is that what your question? Big
My
numbers?
question is, supposed to here is 10 numbers, 10, this side is also, you have 10 or 15 numbers, but that number value is different. Is it more? Because here 1255 is here, then there is also
What do you think the output is?
output is
It's
5,
11.
7, 8, 9, 10, 11.
That is output.
Okay, but that same number which is merged, combined 1, is not coming.
When you have like a, when you have a 7 in.
What is this? What did I write here? If it finds any duplicates in the data, it will merge them into one record.
Okay.
Does it by default take the name of the first column?
Yes.
It's only one.
So this data is merged with this data. Typically what it have? This is my list. This is the total list. This is how it should join. Now once it joins like this, it will find for duplicates. 3 is repeated twice. It merged and kept one record. 4 is repeated twice. Instead of 2 records, we'll have only one. 5 will have only one record. 6 and 7 we do not have entry, so it just stays like that. If it finds a duplicate, it will remove it. That is the advantage of union. Is that clear?
Yep.
The next set of operators that we have, union all.
Basically, you will have a duplicate in there.
Everything will be displayed, irrespective of duplicates. Is that clear? So if you use union all, it will not remove any duplicates. You will have all the duplicates, every single record. A typical join happens here. Is that clear? Now one of the questions that I'm going to ask you guys in the test is give me 4 different SQL queries to display distinct values. 4 queries to display distinct values in a column. Can you give me one?
Unique,
So
not.
you do.
That is a constraint. You have to make sure that you do not talk about constraints. That is defining the properties of the column. I want to display here.
So you can select this thing.
So you can do the union.
And then you do union all.
Why union all?
Just
Again,
union,
you
right?
want to eliminate the duplicates.
Select distinct is your query. Select distinct column 1 from table 1. That gives you distinct values in a column.
Oh, so it doesn't duplicate it.
What is my question? Can somebody repeat it?
4 queries
Four
to display
sequences
distinct
with
values and
distinct
sequence.
I asked you to give me one query. What does this give for the column 1? What values do you get in column 1?
All of them.
How many values do I get? If I run this one?
Just three.
3.
Three.
Paul said 3.
Select department number from No, all of them, right? 14 values,
That's
right?
it, 14.
Why will you get
This
14?
is not distinct.
Why will you get 3?
Oh, sorry. All the ones, like department number. It's distinct.
How many of you know this one? Did we discuss this in the class?
No.
Tell me another query to display distinct values.
Can we do the union?
I don't know. You tell me.
So do select.
Don't ask me.
Select
Tell me the
A
query.
from table 1, union select B from table 2.
Okay. Display distinct department numbers. If you're saying union, it works. What is table 1, table 2? What is column 1, column 2?
Okay, then
I want to display distinct department numbers using union. You were saying we can do it with union. Let me know how we do it.
Select the distinct department number from EN.
Did it run for you? Did it run for you? Okay.
Union, select the distinct department number.
I do not want to use distinct here. I already use. I can just run this one and I'm going to get distinct department numbers. What is the use of having union then?
I said select department number from EFP, union, select department number from department REPT.
Okay. Let's say you do not have department number table, department table. You do not have department table. What do you do? You have only one table that's called EMP, and I want to display distinct department numbers. I do not want to use distinct.
Like
Unique is a constraint. I've been repeating. Just 5 minutes back I told that.
Group by union again. Group by department.
Group by department number is a query. It should give you one record. That is another type. You're gonna get these type of questions in the test, and it's gonna take the complete 2 hours for you guys to write if you practice this way. I'm pretty sure you're gonna take complete 2 hours to write just one query. You have to practice. What does this give?
all the department, all the
You said there are 4 ways to.
I'm not going to tell all the 4 ways. You have to write it.
So there are 4 possibilities.
Yes.
department number.
What does this query give? Same data?
This is by department number.
group by gives you the same as.
What does, we get 14 records here? We get 14 records here. What does union do? If it finds any duplicates, merges into one record. How many records should we have?
Just three.
3. There are 3 duplicate distinct values out there. What happens if I do union all?
I'll give you 28 values.
All the
How many records?
14 plus 14.
28 records, right?
14 plus 14. 28 rows. If you do not practice, I'm going to stop the class right away. I'm pretty sure about it. I mean, if you do not, you cannot answer a single question. It's waste of my time and your time. You can just happily sit at home if you do not want to practice. How can you write unique in select query? You're missing the basics. Select distinct is query 1. Union is query 2. Using group by you can do it. Using having you can do it.
No, it's intersect.
Intersect doesn't give you distinct values. I'm asking distinct values. Next. One thing is I can finish the class anyway. I do not want to finish the class. I want you guys to understand. I've told you in the first class that if you have any questions, come and ask me. If you do not ask me questions, well, there are two things. One thing is you understand everything or you are not even practicing it. That is pretty sure. And I'm pretty sure that if you're practicing SQL, you will have questions. There's no way that you can understand every single concept. Even I still refer every single notes that I've been taught because nobody can remember anything. Every single thing. So it's up to you. If you want to understand, ask questions, or else that I can wrap up the class as soon as possible.
Can you do this? No, no.
What is it?
Select department number from EMP, group by department number.
I told you, right? With group by we can do it. You should tell the answer before I said about group by. Alright, the next set operator that we are left with is intersect. So union merges all the records together, and if we find any duplicates, it will merge the duplicates into one single record. Union all. Irrespective of having duplicates, it doesn't really matter. It merges every single record that it finds in both the columns into one single column. Intersect will display only what? Just the common records. Everybody know what is intersect, right? It's math. What are the common values here?
3, 4, 5.
That is what we have. Both common records in both the tables will be displayed. Okay? And the last set of operators that we have is minus. And this is very important, and there is a little trick sitting here. Alright, before we discuss about minus, tell me if A minus B is equal to B minus A. Is that true or wrong? False. That is false. A minus B is never equal to B minus A. Is that right? The same concept applies here. So before we go there, if I change these queries, let me change B and T2, A and T1. What will be the output?
Same.
The table
Table
name
name will
changes.
change, but value will.
The order of the rows
3,
changes.
4, 5, 6.
The order of the rows.
1, 2.
From the data perspective,
3, 4, 5, 6, 7, 1, 2.
3, 1, 2.
it will be the same data.
The order of the rows will change.
That's okay. Don't worry about the order. I'm just worried about the data here. Does the data change
No.
in the column? No.
But we selected B, right? Starting.
So this is the.
Oh,
this is the
select B from T2, union select A from T1.
The data doesn't change.
The data
It's
stays the
nothing
same.
else changes.
Nothing will change here. It's the same stuff. You do union. You're getting this records, right? Did anything change?
It is
No.
not even changing the way it looks.
It will not change. That's how it is.
So you have 19 now.
Does it really matter if I change the way it looks? I can always sort it. I'm just worried about data here. Nothing. I'm not talking about sorting or anything. That is completely fine. I can put a order by statement next to it. It's always going to be same order. Don't worry about what is not important. Just worry about what I'm talking about the data. So if I interchange this query here or put this query there, it doesn't really matter. Query 1 union query 2 or query 2 union query 1 will always have the same result. Will it have the same result for union all if I interchange the queries?
Same, yeah.
Same for intersect. Nothing will change. It just displays the common values. But for minus, it does change. A minus B is completely different from B minus A. So what is A minus B? So A minus B is, it will find out the differences between these two columns, right? So that is the basic concept of minus. So when
It's like
table 1 or when a query 1 minus query 2 is applied, all the unmatched records in the first column or first table, first query will be displayed. If every single record in both the columns are completely matched, then no records will be displayed. For example, I'm going to grab this data. Let me put it out here. I'm saying A minus B. If I say A minus B, what I'm saying, if every single record in both the columns are same, it will display no records. But if there is a mismatch, all the unmatched records in table 1, what is table 1 here? A. A is this one. Agree? Will be displayed. That will only be displayed. Nothing from the B will be displayed. So what is A minus B? 1 and 2. Let me do it the other way. B minus A. If all the records matched, it will display no records. If there is a mismatch between the records in B and records in A, all the unmatched records in query 1, what is query 1? B, right? that will be displayed. 6 and 7 are the unmatched records.
This, can we look at it this way also? If you take a union minus the intercept. Can you see that as well?
Mhm.
Because the intercept is basically it's the what's matching.
You're applying 3 sort operators then. You're first applying union,
Right.
then applying intersect,
Right.
then applying minus. Here you're getting just minus.
I'm just taught you
Same stuff.
not necessarily.
But it always displays the left out data from the query 1. That is the only thing that it displays. It doesn't display left out data from query 2, because what is unmatched data in this one? 1 and 2 in here, 6 and 7 from here. If I do A minus B, it will display only unmatched records from query 1. It doesn't care about query 2. If I do B minus A, it will display unmatched records from this table, because that is my first query. Right? Is that clear? So if I go here, this is my query 1. Table 1 is sitting on top of minus. Table 1 minus table 2. That means this is my first query. Agree? So if I do this one, the data will be, I look up for all these values in this data.
Good.
Whatever data that I don't see here, that will be displayed.
Can we get a scenario where, I would say more like a real life scenario where you are applying this concept?
I can. That is my data. Is that clear? Now let's get back to a scenario and see what we have. Now, what do we as a QA do in a job? I know testing. How do we do it? What are we testing?
Use case.
Requirements.
Data.
Data.
Where do you need to test the data?
Same data,
You begin with the job.
free of charge.
One answer.
It's according to the requirements, or bug free,
What is according to the requirement? I have data.
like clients need.
Like there is no duplicates.
Why no duplicates?
To confirm functionality of.
Just verify the.
No.
Should be usable?
Hmm? Usable? What is usable?
You mean the data or why do we use?
Why do we test data? Why do you need to test data?
To double check it and make sure it's a bug-free, clean product is given to the client.
Make sure that.
Why do you think there are
data
bugs?
goes into the right tables
We're
and
just doing a
columns.
double check on it.
No. Why do you think the data will be having bugs?
That's what you're confirming.
Yeah, but why is there a requirement of there'll be bugs? If the data is already there, why do you need to test it?
Well, be sure that you'll be able to retrieve what you are, sending the command to retrieve the data that you're looking
To see whether it's working properly.
Why do you need to work? If already data is there, sitting out there from hundreds of years, why do you need to test it now?
Because new changes always.
She is somewhat right, comparing the report with the database. There is a data movement. If the data is already sitting out there, why do you need to test it? If there is a process that has been applied on the data, if the data is moved from one place to another place, or we are changing some part of the data to be displayed in a different way, then comes the requirement. Then you test it. Otherwise, why do you test it? If the data is sitting out there, just like that, why do you test it? There
If
is
there is any change, we test it,
The requirements.
That's what I'm saying. We need that change. That is, we are moving data from one place to another place, one data type to another data type. That's what I want. We move the data. The data is moved from one place to another place. Then you test it. There comes a requirement and you test it. Is that right? So all I need is the data is moved from source to target. As a QA, these are your keywords. And this is what I actually wanted. Thought somebody will answer. Data is moved from source to target, and I need to test the target data, if it's moved correctly or not. That is the basic concept. You pick any project as a QA. You should have a source, you should have a target. When you test something, what do you compare it with? You're testing, you're giving me all requirements. I'll test it this way, test it this way. I don't want that. I have a source, I have a target. Target data is developed by the developer. You apply all your SQL knowledge on source data. Whatever data that you get, you compare it with the target data. That is what you do. Is that right?
Yes.
Now, when we test this, let's say I pull up data, select start from, let's say I'm testing primary key column from target, gives me primary key column data from target. Is that right? I'll say select column 1 from source. This will give me column 1 data or the primary key data from source. Agree? Yes? Now, the way we test is, we check the counts first. If the count matches, then we go to the next step. But I'm going to directly show what we do with minus. So if I say select column 1 from source minus select column 1 from target, what is the data that I get?
Unmatched
Or the unmatched data
from source.
Tell me in a nice way.
unmatched data that is there in the source, that's what we get.
What does that mean?
That is data which is not being matched.
I understand that.
Target data.
I understand that.
And the leftover data which is
I understand
not
that.
there
1
in
minute, 1 minute. I understand that. That unmatched data from table 1 will be shown. But what does that mean?
That means
That
that the target doesn't have that data which is there in the source, but it's not there in the target.
That is what I wanted. So whatever data that we now have, so when I'm pulling this query, what am I testing here?
If there's any excess data in the source which was not in the target.
Can you repeat that again?
If there's any excess data in the source which is not being displayed in the target.
Or the data missing.
That is correct.
Yeah.
So when I pull this query, I'm assuming that every record that I bring up here in this query should be available in target. Is that right?
Yeah.
Because I'm moving data from source to target. Yes? So when I run this query, what I get is all the data in source. So typically my requirement here is I should display all the records in source into target, right? But this query will give
No records.
all the records in source that are not available in target. If a record is being dropped when it moved to target, let's say we have 100 records here. In target we have only 98 records, right? So we have 100 in source, target has 98. So if I run this query, the output is 2 records, because there are 2 records in source which are not available in target. That means there are 2 records which developers dropped when they're moving the data from source to target. Is that right? So this is how you find the duplicate, the records that are dropped which didn't make it to the target. Okay, so will that finish up the testing? One way it does, but there is another way to test it too. Because from source to target, that's what you do. From source, whatever records we have, we should have every single record in target. Right? So if I do this, I found 2 records, put difference, right? Now, let's say in source I have 100 records, and target I have 115 records. If I run the same query, what is the difference here?
100, I mean, 0.
Something is updated on target.
It's 0 basically. Just
It
like
will not
it's
say
zero.
anything, it will be zero.
All I need is what is the difference? Why?
Because there are no unmatched records in query 1.
Because there are no unmatched records in query 1. Every record in source is available in target. But there are more records in target sitting out, which are not coming from source. We will not find that using this method. So when you are testing something, you have to do both A minus B and B minus A. So if I go and change my query to all the records in target which are not available in source. That means these are additional records in target which are not coming from source. You are sure? That's what we need to find. That is an issue. We don't know how these records are being populated. So this one will give you 0. But if I say this one, target will have source. Let's say this is 98, this is 100. This will be what? 0, 0. 98 records in target. So if this is 115 and this is 100, you'll get 15 records. So if I do A minus B and B minus A, these are the mismatched records. We got 2 defects. So whenever you test your application, you have to make sure that if you're using minus, you have to test both A minus B and B minus A. Source minus target and target minus source. Is that clear?
Yeah.
Questions? Done? So if this ends set operators, these are the 4 types that we have as part of set operators, and that is all we have. You guys understood this one? Was that clear? So minus is very important. Union and minus, we use it generally. Union all intersect pretty less cases, but union and minus, yes, we do use it a lot.
So intersect is just the matched ones from A and B.
Is it clear? Done?
Yeah.
So the next concept that we have is joins. How many of you are ready for joins?
Alright.
You ready?
Yeah.
Fresh mind still?
Oh,
Let's take a 5 minutes for
Right now? I'll give you at 11. So let's start joins. So we started using multiple tables here, right? So before we go to joins, is this true? Can we do this? Select EMP number from EMP, union, select EMP number from EMP, union, select. Can you do this?
you have this as well?
You can join more than one columns with the same table.
As far as it set,
You have to.
has the two conditions,
Okay.
takes care of the.
What about the
condition.
data? If you think this is correct, what about the data?
14.
14 or more?
14.
I'm applying 3 times.
It's employee number, so employee number, it's
Same.
14.
14 rows.
If you do union all, then 3 times.
So I can put I can merge multiple columns too. Ename, same stuff. Okay? Department number if you want to put, or any other.
But one question I had is, what if like there are 2 people who have the same name? And if you're doing 3 records together and the 2 people who have the same name, what will happen?
Merge it. We'll lose a record.
And the employee number will also not show. The employee number or the hire date.
If you put employee number, then it will not merge.
Oh, okay.
Now this is the combination that will search for.
Okay.
If it finds a duplicate in this combination, then yes, it merges. If it doesn't find a duplicate in this combination, it will
All
not.
3 should be.
Yes.
So each time it's gonna take it only from the first column.
This is the complete condition.
No, I understand that. However, if it says, say you were to merge it by the department, the first combination is a department number. So it has common values 10, 20, 30, right?
Mm-hmm.
And then if you do department number and email.
Mm-hmm.
So the very first time it does it, say department number is 10, 20, 30, right? And there's multiple people in department 10. So when it picks it up the first time, does it just pick up the first record that has department number 10?
No, that's what I'm saying, right? It's a combination of records now.
It displays all the
It will display all the records because there is no combination. It's something
The
like
entire combination has to be a duplicate.
it's something like group by, same stuff.
Okay.
That's why you're getting duplicate value. You can display duplicate values, non-duplicate values here.
Only if the combination is the same, then it will both of them.
It will look for 1 and 10 and Clark if it's repeated or not in the data. If it repeats, it will merge them together.
So it's going to look at all the columns that
Of
you
course,
put
yes.
together and see if that has a match.
Yes.
If you put 3, like you are repeating the union, like, then I think it's like 3 different tables try to match at one time or reduce the first union and get it, or put table and then it's trying to merge.
When it joins,
Yeah, whenever you do union.
this one will apply, then it will apply to this.
On the result set of.
But you will never see. It's in microseconds. Results is always one single set. Back end, yeah, it works that way.
But if you have different operations, is there any priority of something else? If you have different set operations. It just goes in the order whatever.
Yes. First it will apply this, then it goes to the next one. Okay, next is joins. So there were two rules for set operators. One is what? Number of columns and data type should be equal. In joins, we do not have something like that, nothing like that. But we have to always join on a same data type column. That is the only requirement that we have in joins. So there are 7 different types of joins that we're going to discuss in the class. We'll start with equi-join, a non-equi-join, inner join, cross-join, left, right, and full outer joins. So these are the 7 important types of joins that we're going to discuss. And to understand this, I haven't discussed the concept called foreign key, right? I said I'll discuss it when we are at joins. So as you guys are now aware of all the different data and writing SQL queries, it will be a little easy to understand this one. So select star from employee table. When I apply this, or let me open up description of EMP table. In the table, it says something called foreign keys department number. So these are the columns that I have here, right? If you look at the data here, I'm going to write down all the column names for you guys. EMP number, e-name, job, hire date, manager, salary, commission, department number. These are the columns that I have in employee table. Agree? Let me run another query. It's with something called department table. What are the columns that I have here? Department number, D name, and location, right? So if we look at the employee table, we get 14 records and 8 columns, right? In this data, we have 10, 20, and 30. We have a bunch of records. I mean, we already discussed this concept, but we have 10, 20, and 30 different distinct records. What is 10? It's accounting. But where are we getting this data from? It's a different table that we are getting the data from. Is that right? We do not have this table, detailed information in employee table. In order to find what department number 10 is, we need to switch to another table and see what is the record that is associated with department number 10. In that data, I'll see that the location is New York and the department name is accounting. Is that right? So there is a link between employee table and department table. Is that right? And what is the primary key column here? Employee number. If you look at the department table, what column can be the primary key column? Department number, because these are the distinct numbers and for every department we'll have only one department name. Yes? So department number is a primary key column in department table, right? So these type of columns, in order to understand or to get more detailed information in other tables, we have to link the common columns together. So in employee table, So every table has only one primary key column. Agree? But they can have multiple foreign key columns. And in this column, in this table, the foreign key column is department number. Because using this column, we can link to another table which will give us detailed information about that particular number. People might ask, why do we need this? We can just have accounting written here instead of department number 10. What is the use of having department number 10, 20, 30, 40? We can just have everything here written in the same table. Is that right? Tell me why. Whoever said yes. Why do we use or split the data into another table?
The data is every time we don't manage. There are two tables in the same, can be confusing.
It will not be confusing.
Here it's a simple example.
No, it will never be confusing. I mean, you will have the same data.
It's easier to change the data. I mean, if you have like one table for just the name, you can just change it there and it will, if it's linked to the other tables, it will
Probably
just
that,
there.
yes. One is size. So here, in department table, if I'm storing department number 10, so this is one of the major tables, right? Employee table. You'll have similar type of tables in companies too, where you have hundreds and hundreds of records or millions and millions of records. And let's say for same department number we have, or so employee table, we have 100 records. In that 100 records, we are using department number. Instead of department number, if I put accounting, I'm using how many? 10 bytes of size. Yes? There are 10 characters, I'm using 10 bytes of size. How many I'm using if I use department number? So this is just one-time storage, whatever I'm doing here in another table. If I create another table for the same data set, there is no redundancy. I'm removing the duplicates of having accounting in every 100 records. If I put accounting in 100 records, it's going to take a lot of space. Instead of that, I put accounting once in a separate table and link the number 10 or 20, whatever number that is, in the table. I'm going to save a lot of space, right? So this is a basic concept, saving space and for flexibility of changing the data. So if I go, or if let's say department number 10 is changed as department name, okay, if it changes department name to, let's say, IT, you do not want to display it as accounting, they want to change it as IT. If I do not have this table, I have to go to employee table. Let's say you have million records with the department name accounting. I have to change all the million records with the name IT. Or if I have something like this, I go to this table, I change one record. Because department number 10 is linked to all other tables, which is the easiest way, I change it. And it's going to change in every single record, because every time you make a call to this table, on that particular column, it's going to go and talk to this table. Agree? And it's going to pull whatever record that is associated to it. If we change it here, it changes in every single table. That's how the data models are created. Data warehouse, all the data like this. It is structured in a nice way where you do not have any redundancy, and it's easy to access. Anytime there is a change, it should be easy to fix. Okay? So when we have a join, when you have a link between one column and in a table to another column in a table, typically we join on primary key and foreign key columns. So the foreign key column in this table is linked to the primary key column in another table. Do you understand the primary key column concept here?
Yes, it always have to be like.
It doesn't. But generally the data models that we have, we generally directly link it to primary key columns, because it always makes sense. Because if this column has duplicate values, it will be very tough to actually create a join between them. So what we generally do is, this column already has duplicates, because this one has a primary key column here, and this is repeated multiple times in that particular column. 10 is repeated multiple times. So if I have again duplicates in another column, another table in that same column, it will be pretty hard for you to make a join. So they try to always come up with something called a primary key column in every other table, every table will have a primary key column for sure. So if you try to join to that particular table, then make sure that you join on primary key column.
So it's just convenience for us.
90% of the times, I could say 95% of the times you'll be joining on primary key columns. Okay? So this is the column that we'll be using to link both the tables. Make sense? Let's write a small syntax for join. So you have to understand this concept. Every table, if you're joining, you have to have a relationship. If you do not have a relationship, you can never join those tables. Relationship is based on primary key and foreign key columns. So you have to look for those columns whenever you open up a table. In this one, it's actually not showing, but typically when you describe and put that tables, right? Is it saying primary key here? PK is 1, right? Similarly, you will have foreign key also shown. There will be a column called foreign key, which specifies what is a column. Or you can always play with the different stuff here. Or the easiest way is go to data model.
Internet is not working.
You guys looked at the data model, right? The other day I showed you data models. No? I believe I showed you.
Okay. Just had some questions.
It looks something like this. Table, 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 table. There will be columns. Showed you this one? I'm pretty sure I showed you.
First and second class.
So this foreign key column is linked to the primary key column. This foreign key column is linked to a primary key column. So that's how the structure goes. Or we'll have one big table.
So the foreign key also has conditions, like the primary key has.
What conditions?
Like primary key has unique properties.
Mm-mm.
The foreign key also has similar conditions that it should have unique
No.
properties.
No, no, no. So you'll have something similar to like this model where every rectangular box that you see is a table and they're columns, and they'll specify every table will have a primary key column And if there is a foreign key column, we'll specify with fk. And how? So this column 2, if you want to create a relationship between these two tables, you have to join them on the primary key column here with column 2 in this table. So if you join this table to this table, we have to join on column 3 and column 1 in that table. If you want to join this table, column 4 and column 1 in that table. So you'll have a bigger picture of what tables you have, how do you create relationship between those tables. All this information you can find it in a document called data model. Make sense? So if you have something similar to this, yes, you can use it and understand joins between tables. And you will have to use this document to understand joins, because you cannot, by look and feel, you cannot say that I can join on these columns. You have to have the data model, only then you can understand. Every time you go to a company, if somebody asks you to write a query, ask them the data model. Look at this and try to understand how the columns or how the tables are related to each other. On what columns? Okay? Let's start.
You used from every table you used different column, right? So my question is department number. Let's say primary key and department table. So can you use that primary key in multiple tables as a point?
If other table also use department number, yes. Now for the joins, let's start with equi-join. So whenever, as I just said, whenever we have one or more tables, we create or we apply a concept called joins to merge those two tables together and bring up the data. So equi-join is a similar concept. The way we write joins is select. I'm going to use the same two tables. Okay? Select star from EMP E. How many of you know what is EMP E? Alias, right? Table alias. Whenever we use E, every time you want to display a column, you have to put E dot column name. Is that right? In order to add the next table, all you have to do is put a comma after this one. This creates a join. That is a join.
How?
And is this just for the equi-join or is this just a join?
Just showing the syntax. So whenever you want to bring data from multiple tables, all you have to do is in from condition, put the table 1, comma, table 2. Typically when you have a statement something like this becomes a join statement. But if I run this, what did we discuss? What will the vertical joins or the joins do?
You just add columns.
It will just add the columns. It will not increase the number of rows if the join is perfectly right. Right? That is our concept. So how many columns do we have? Should we see? If I apply this join,
11.
how? 8 plus 3?
Yeah.
How many columns do we have in employee?
8.
How many in department table?
3.
8 plus 3 is 11. So we should see 11 columns and number of rows.
Total. 7.
Do we increase number of rows?
No.
14 rows. 14 is the maximum, right? In both of them? This has 14 and this has 5 or something. So typically we should see 14 rows. Let me run this. How many columns do we get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Are you good with rows? Sorry, columns?
Yes.
With rows?
70.
I'm getting 70 rows. What did I say? If my join is correct, I shouldn't increase the number of rows.
Right.
I can always decrease depending on the join, but it shouldn't increase the number of rows. Is that right? Then how do you think the number came up? Any guesses? I'm asking guess.
Yeah, because there are 5 departments and it's 14 times 5. It's really around 5,000.
14 times 5 is what? That's what you get. 14 records in employee table, 5 records in department table. Every record in employee table is joining 5 times to the department table. So it came up with 70 records. That's because I created a join, but did I specify a relationship?
No.
What did I talk about? We should have a relationship between 2 tables in order to join. That is on primary key and foreign key columns, right? I haven't did anything here. I just added tables. So these type of joins, when I join something like this, without having any join, without having any relationship, this is called a cross join. This is a type of join where we do not specify any relationship, just add the tables, and every single record will be multiplied with the number of rows that you have in the other table. So this is how we get. The output always is a Cartesian product. 14 times 5, this is called Cartesian product. Alright, so this one is a type of join. If you do not specify the relationship and you get the output this way, you can call it a cross join, a Cartesian product. Okay? Clear? Now, if you want to have a proper join where we have exact number of rows, exact number of columns, we are able to achieve the number of columns here. I agree? Now let's start getting the rows. That is by applying a relationship between both the tables from EMP E, comma DEPT D. Until here everything is fine. Now we need to create the relationship between those 2 columns. Agree?
Yeah.
The way we do it is in where clause. Where? What are the columns that we are working about? E dot department number, right? This should be equal to what? This is how I specify a relationship where every record in employee table should be equated on department number column. If I do not do this, so every record, Smith is equated to 10, Alan is equated to 10, Ward, every single record, all the 14 records are equated to department number 10, again all the 14 records are equated to department number 20, and that's how we're getting 70 records. But if I do this one, this employee table has department number 20, right? Smith has records to be, Smith is from department number 20. He should be equated to only department number 20. Typically, if we have the join correctly. Agree? So using this, I'm specifying that equation or relationship wherein it specifies that department number 20 should always be equal to department number 20 only. Now, let me run this. I'm getting 14 rows and 8 columns or 11 columns. So, in department table, what is the column name? Department name, right? The primary key column. Here, in employee table, it is still department column, right? So when I display it in the output, if I have a same column name, what it does is, it just puts, SQL just puts, or Toad puts department number underscore 1. Because these two have same column names. Agree? So now using this one, how did I join? Equal to. Is that right? I used equal to sign to create a relationship between these 2 tables. Yes? This is called a equi-join. Yes.
Like in this case, it displays two columns, department and the two columns. So if I needed just one column. I wanted to merge the two columns.
Why do you want to make it complicated?
Just choosing column.
Select. Just choose whatever you want to display. Don't wantedly make your queries complex.
No, I was thinking maybe there was.
Select statement. Select what columns you want to display. That's it. Right? So, is this clear? Everybody? Let me create another EMP table. Copy of EMP table. How do we do it?
Create table as
Can somebody tell me? From here? How do we create another copy of EMP table?
Create.
I know with create we can do it.
Temp 7, whatever. And yes.
Do it. Do it the right way. Just set something right.
Create.
Type it and see if it works. Create temp 7.
Temp 10, whatever.
Try it. Let me know if it works.
A copy of the EMP table, right? Table, table.
Start from EMP.
It works. I'm inserting a row into the employee table. How many records do I have in employee table?
14.
In this one.
16.
I inserted 2 rows into the table. Right? Let me create the join now, equi-join. How many records do I get? 16, right?
The table name is in.
What happened?
The table name is in.
Department.
7E and it's
DPTV.
16, right? What are the number of rows that I'm getting? Why?
Because it's not recognized.
Department.
So when I apply a join, the data that you get is always matching records. The reason I added a couple of rows is because employee table has only 3 departments, 10, 20 and 30. And we have those records in department table. Yes? So I added some data which is not in employee table, which is not in department table. I added a couple of records with department number 60 and 70. Right? So now this is my data set. EMP7, the data that I have here is my data set. So when I apply a join here, now with the department table, all the records until here has an entry in department table. Is that right? But 60 and 70 we do not have an entry in department table. Do we have a record
No.
which specifies what is department number 60 and what is 70? No. So it will not display anything. So these 2 records will be excluded. So one thing you have to remember is whenever you apply joins, one bottom line rule is you always display matching records. And at least until what we learned right now. So joins displays always the matching records. Depending on the type of join, there are add-ons to the joins, add-ons to the data set that we could make. But always joins, if it's a plain join, it always displays the matching records. Is that clear? So what all we need? We need a relationship that creates the join between both the tables, and the data that is displayed is matching records from both the tables. Okay? Is that clear? Everybody?
Yeah.
So whenever we use is equal to, that means it's a equi-join. Let's take a break. 10 minutes. Okay. The next set of join is called non-equi-join. So it's the exact opposite thing. Equi-join we use is equal to. Non-equi-join we will not use is equal to. Without using that, we'll create a relationship. Let me open up another table for which we can understand the non-equi-join. So there is a table called sal grade. Okay, even this is a predefined table, and this has some data too. If you look at the data, we have grade, low salary, high salary, some stuff, right? Now, looking at this one, so I'm going to pull up this sheet here again. This is the employee table data. Sal grade is grade, low sal, and high sal. So we looked at this combination, right? So here we had a specific column that we could equate to. Is that right? Do we have a similar type of scenario here, where we have one column that we could directly equate it to this column? Do we have anywhere grade? Do we have anywhere low sal? High sal? We do not have a specific column in both the tables which we could join on. Is that right? There is no way that we could create a equijoin relationship. We cannot equate anything to a specific column here. Is that right? Now when we have cases like this, there are other joins that we could use. So looking at the data, what type of explanation that we could give with this data? What are we showing in this data?
Grade-wise range, salary.
So we are displaying grades. How are we displaying grades?
Based on the salary.
Based on the salary. Is that right? Now, do we have a salary column here?
Yes.
So now, looking at the salary column, or based on the salary column, we are trying to come up with a grade. Is that right? So now this is a typical example of not joining to the primary key column. In this table, the primary key column is grade. Yes, and but we do not have anything that is related to grade in the employee table. So we are joining it on some other columns in the table, which makes more sense to create a relationship between both tables. So salary, if it falls, so the way the data is structured in this table is, if the salary falls in between 700 and 1200, it's called grade 1. If it falls in between 1201 and 1400, it's called grade 2. That's how the data is structured in this table. So if my requirement is display the grade of the employee based on the salary, if somebody comes up to you and asks you to display something like this, display the grade of the employee based on salary, where do you get the employee details? Employee table. Where do you get the grade? It's in sal grade table. So you have to combine both the tables together to get the common data. Is it right? So the first thing that you do is select star from EMP7. I'm going to put, this is my employee table data, E, comma, sal grade. We'll put some S. Next, I'll have to have where clause, where I'm specifying the relationship, right? How do we specify now? Okay, greater than?
Greater than that range.
Greater than low sal.
Less than 12. No, actually,
Greater than low sal, right? Do you specify?
S dot.
S dot low sal.
And
Less
less than S dot high sal.
Is that right?
And high sal. Then grade is equal to.
Grade is
Greater than.
Applying to invert a new SQL. That's it. You have to specify E dot sal and condition, multiple conditions. We created a relationship. We have rows less than 14, right? Which makes sense. But why do we have less than 14?
Can you provide us a relationship instead of having like two, since you have the ECL and it's not one time?
What is that?
I was asking if we can combine those relationships instead of having two separate ones. Will we make it just one?
How do we combine it?
where the each salary is in between.
That's what I want. Between. So this query gives me 14 rows, right? S dot low sal, S dot high sal is equal to E dot sal. This is one way of writing it, or we can write it using between. Right? What are we displaying? Employee and his grade. His salary is 800. Is it in between this range? So his grade is 1. This guy's is 950. It's in this range. Same with this employee. 1250. He's in grade 2 because his salary is in a particular range. So we created a relationship between this table and the sal grade table without using is equal to. That is using relational operators between. So this type of joins where we haven't used equal to are called non-equi join. Make sense? Did I use join here? Sorry, the equal to sign here. So when I do not use a equal to sign, okay? Question? Is that clear, everybody? So even in this record, even in this query, if you even non-equi join, the data that you're displaying is matching records. I'm not displaying anything that is related to 50. What is, yeah, right? So only matching records will be displayed. Clear?
So even with the EP join, it's not mandatory that the both, like from the where condition, it needs not to be the primary keys, right?
The next set of joins is inner join. So you guys have understood both equijoin and non-equijoin, right? So all we are doing is displaying matching records. That's what we are trying to achieve using joins. Next is inner join. So inner join is written with the keyword. So from here on, I generally write all my joins using these keywords. So this is one way of writing join, putting the relationship in where clause. Or we can specify the where clause at a different location, the relationship. So select star from EMP7E sal grade S. This is how we typically write until now, right? When we create a join, this is how we are writing. So the little change that I want to do here is when I'm using inner join, I will not have any comma or anything like this in between tables. All I need to do is put inner join keyword in between them. So table 1, inner join, table 2. Okay, so this is how I specify the join, but I need to also display the relationship, right? So table 1, inner join, table 2, on is the keyword. Inner join is the keyword again here. Inner join, sal grade, on, what is the relationship? E dot sal, same thing. Whatever you written where clause, you can just throw that here. It works exactly the same way. So this is the relationship that we have given in the where clause until now, right? So this condition can be given in from clause itself. So I'm still in from here. Table 1, inner join table 2 on that particular relationship. So this will explain, or this will let the SQL understand that these two tables are joined on this particular relationship. So this is just another way of writing the above query, and we are using inner join keywords. We are not using comma anymore.
What would be the obvious advantage of using inner join instead of non-join?
Okay, I can use multiple, I can use both equijoin and non-equijoin in the same query. If I need to join another table, so this is one table, right? Joining one table. Typically when we join multiple tables, select star from table 1, comma, table 2, comma, table 3, and so on. You can join any tables that you want and display all the relationships in where clause, right? Table 1 is equal to table 2 and table 2 is equal to table 3 and so on. That's how typically a join is written. Is that clear, everybody? This one? Now similarly, if you want to join multiple tables using inner join keyword, the way you can join is, this is my first join condition, right? I've given two tables and their relationship. Once I specify that ends the relationship. This statement ends here. After this, if you want to join another table, all you need to do is write the typical word inner join. I'm just doing it, I can just write it here, inner join, it will work. I'm just formatting the query. Okay, inner join, what is the other table that we department D. On what is the condition?
E dot department number.
Because we specify, we just added the table here. I do not need to specify again EMP7. That is only one time I'll specify. Table 1 joins with table 2. After that, if I have another join that you want to make, I'll say inner join table 3. All I need to do is I need to specify the relationship. If I specify the relationship correctly, then it will join all the tables correctly. If I mess up this one, it will mess up the data. So all you need to do is find the correct relationship between the tables. So this one, when I join, this is the relationship. I'm done with it. Now inner join department table. This department table is related to what? How do we join? To employee table, right? So all we need to do is on D dot or whatever, E dot department number, department number. I do not need to specify join with this one because I do not have a join between department table and salary table. All I need to know is every single table should be related to each other. Employee table is related to salary, yes. With this condition, yes. Employee table is related to department table, yes. With this condition. Now every single table is related to each other, isn't it or not? So when we have cases like that, the join will work perfectly fine. Let's say if some table is hanging around, inner join, I can add up any number of joins here. Inner join, sum table, let's say temp 7. I do not specify the relationship. Now this will become a Cartesian product because this table doesn't have any relationship with these. How do we specify relationship? Is with on condition, right? For every other tables that I've joined, I had on condition and created the relationship. This one doesn't have anything. So this will throw a Cartesian product. It will still run, but product, the output is not what we wanted. So you have to be very careful when you join multiple tables. So when I run this, how many rows should you get?
14.
You'll still get 14 rows. The rows will not affect until your join is correct. Right? Now what are the data that we're getting? We are getting the employee table data until here. Yes? We are getting the salary table data. We're getting the department table data. If somebody comes and asks you, display employee name or employee number, E dot EMP number, E dot E name, their hire date, E dot hire date, their salary, E dot salary, their grade, S dot grade, and their account, their department name and location. I'll say D dot D name, comma, D dot LOC. So Smith is hired on this particular day. His salary is 800. He's from department number, he's from research department and he works in Dallas. Make sense? So we joined 3 tables now and displaying some data. How many of you did not understand this? How many of you want me to repeat this? Why? What did you not understand now? What did you not understand? Tell me. I'm going to start from there. I'm going to not repeat everything.
Just this inner join, the whole thing.
I know. I'm just talking about inner join. I'm not going to repeat every single thing. What did you not understand? What is the data that it displays?
What is the data that we display?
Matching records?
Yeah, I think because it just took the grades.
So do you have a doubt in what we have here? Where is that equi-join query that we written?
What?
This one. Do you understand this? Equi-join. I create a relationship between both the tables. If I do not create, I was getting some junk data, 70 records, right? The way I create this join is having a relationship. Similarly, that was with the equi-join. Even if I do not have a relationship between those two primary key and foreign key columns, I can still create a relationship that is using a different type of join, that is a non-equi-join, where I'm not using is equal to and still able to create a join, right? So every time I create or join 2 tables, the mandatory thing that I need to have is relationship between those 2 tables. Yes? So whenever I join 2 tables, the mandatory thing that I should have is relationship. So similarly, when I come to inner join, it's the same stuff what we have in equi-join and non-equi-join, but I'm writing it in a different way. Inner join doesn't have anything in where clause. It just has everything in from clause, and it's written with a keyword, specific keywords. This is the keyword that I specify. If I bring up this query, these 2 are same queries, but the way I written it is completely different. Here in from clause, I'm putting comma and adding all the different tables that I have and creating relationship in where clause. This query can also be written using inner join method. This is table 1 inner join, no comma, nothing. This is the difference. I'm using table name. The condition that I'm giving here, instead of in where, I'm using a keyword inner join is related to the keyword on. So whenever you use inner join, you should have the relationship specified in from clause. I do not use where anymore. This is how you have to write it. That is a syntax. I cannot help if you have problem with syntax.
No, that's fine.
So this is how you have to write the inner join query. So relationship in where clause has to be shifted to from clause. When you move that into from, it runs that way.
Can you use the inner join query in conjunction with one of the other queries?
What does that mean?
Like say this one is inner join, and next after that you've written inner join department on department number is that part of the query.
Tell
Where
me
you
what
do
did
the
I
inner
write.
join
Tell
on.
me what did I write.
Okay, you've written inner join the department number D on department D on basically it was department number no E dot department number between no you forgot the okay on E dot department number between no not is equal to D dot department number. So instead of doing that instead of keeping this in inner join, can you do an inner join and the next one saying where department number is equal to?
If you're using inner join,
Mm-hmm.
you have to have your relationship here.
Okay. No. What I'm asking you is, can we do the inner join query in conjunction with a equijoin?
I understand that. If you're using inner join keyword
Okay.
here and adding another table, you have to specify your relationship in the from clause.
Okay.
There's no other way to do it.
Okay.
If you do not want to use it here,
Mm-hmm.
you do not want to write this one here,
Mm-hmm.
all you can do is put a comma
Okay.
and join the table department D. Then you can specify this in where clause.
Okay.
If you want to use inner join keyword, there is no way that you can write your relationship in where clause. You have to write it in from clause.
Okay.
This is the easiest way, at least for me. If you guys are comfortable writing in where clause, you can always do it. But in where clause, I generally write all my filters. In from, I join all my tables. That's how I generally go when I create. Because if you join all your tables, we can do it. It's no crime. You can do all your joins in from clause too. But I feel this is more comfortable for me. Writing it with the clause, that keywords. Is that clear? Any doubts? Again, what we display is matching records. Same stuff, it runs. But the way I specify the relationship is different. Okay? Questions? Alright, let me show another thing here. Tell me if the output changes. Now the department number is in front of inner join, and after we have employee table. Will we have a different output?
Does it sort it by the grade?
Where did grade come from? I'm asking about this query. Look at this query. Difference between them. Are they same or not? Why? If it's same.
You're joining the both tables on the department name.
So what?
These are the- What will you say?
The relationship at the beginning, I mean, you have one that has
What does this
primary key.
what does this display?
We have a specified foreign key.
14.
What did I not display?
We have specified the foreign key and the primary key relationship.
What is this? What does this display?
It's the same thing.
Matching records from both the tables.
Yeah.
Start talking that way. What does this display? Is the output same in both the queries?
Yes.
Matching records, does it differ?
No.
Both the queries are same. You write it here or here.
Wow.
The table 1, inner join, table 2. For inner join, it doesn't matter. But for other joins, the next joins that we're going to discuss, having the table on the left side of the join and having the table on the right side of the join does matter. But for inner join, it doesn't really matter. You can have the table here or here. Output doesn't change because all we are doing is displaying matching records. You will have the same number of matching records if you run this one, or you'll have the same number of matching records if you display this one. Do we have a difference in matching records? No, it's the same query, we are writing in different ways. The difference makes only when we're displaying some other records other than the matching records. Is that right? So inner join, table 1 can be on the left side of the inner join or on the right side of the inner join. It doesn't really matter because all we are displaying is matching records. Clear? Next. The next type of join that we have is left outer join. This is where joins get complex. Until now it was pretty straightforward. All we are doing is displaying matching records, right? Everything that we discussed until now is just displaying matching records, right? And we've joined multiple tables. We joined 3 tables. It didn't really matter because all we are displaying is matching records. But from left outer join, from this particular join, is going to get a little complex. I wouldn't say completely complex. If you understand it, it makes sense. It's something similar to minus what we discussed. Alright, how do we write it? What is the inner join query that we wrote with the department table?
So let's start from department B.
Inner join
On. Right? For writing a left outer join query, all we have to do is change the keyword. That is the only thing that changes. Instead of left inner join, I'll put left outer join. How many records are we getting here in this one? 14. That means what? Is displaying only matching records. How many do we have in employee table? This one? EMP7 table.
16.
Those records are not there when I just checked, right? That's because I didn't commit. It didn't save. It shows up for that second, every time it refreshes, it just leaves it. So now I have all my 16 records, right? When I do inner join query, it's displaying 14 records. So left outer join, what it does is same stuff. Bottom line is, you pick any type of join, it will first display the matching records. You have to be very careful about this one. Whatever join you apply, it will first display matching records. After displaying matching records, whatever variations we have with the join, that will be displayed. Even with the left outer join, the first set of records that we're going to display is matching records. That is 14, right? After this, any records that are left out in a left table, this is the left table and this is the right table, is that right? If this is my join condition, the one that is left to it is this table, the first table, and one that is right to it is the right table. So any records that are left out in the left table will also be displayed. If I do an inner join, I'm displaying only matching records. Agree? Now if I run this one, how many records should I get? 16. I'm getting 16 records.
Right.
Right? That is because all the records that are left out in left table will also be displayed. Make sense? Then what should we have for the same columns? We cannot have anything left out like that, right? In the right table. So when we have matching record, let me open this up again. When we have a matching record, until here it's the left table, right?
Right.
If we have a matching record, where corresponding data related to that particular column is being displayed. Is that right? What happens if we do not have an entry? We do not have entry for the last two columns, right? It's last two rows. But we are forcing it to be displayed because of left outer join. Yes? Then what should it have for the department number, department name and location in right table? We should have some corresponding data to be displayed, right? We cannot have 16 rows for the first 8 columns and 14 rows for the second 8 columns. Second 2 columns, right? We should have equal number of rows in all the columns. What do you think it will display? It is null. Okay, so the bottom line here is left outer join will display all the matching rows from both the tables. Next, it will display left out rows from the left table, and all the rows corresponding to those rows in right table will be null. Let me write it.
Way to find if there is data added into that, then the null we have to change.
What is it?
We're displaying null at this point of time, but at a later point of time, if data is, we want to add data to that,
What am I doing here?
we'll join it.
Can we?
Select is read only. I'm not saving this data anywhere.
Before you move, you have 16 records, so there is a no. Okay, got it. I can see.
Last 3 columns have null values.
Right.
So the notes here is left outer join will display all the matching records from both the tables and will display left out rows in the left table and the corresponding columns in right table will be displayed as null. Is that clear? Yes?
Since we didn't insert the data for those new two rows, that's why it is displaying as null there, right?
MGR inherited? Yes. I inserted only are you talking about these ones?
The null, yeah.
This one? What did I just say? What are these three columns? Where are we getting these columns from?
The department.
I do a left outer join. When I do a left outer join, I should get all the matching records. These are the matching records. Then I should display all the left out rows in the left table. What are it? These two records, right? That is until here only. These three columns are from right table. So all the right table columns corresponding to these two rows, because it doesn't have any data that is related to it, will be null automatically.
If it has the same data, then it will display those two.
It will be under matching records. Okay?
So, I just have a question. In vertical joins, all we're doing is, in join, all we're doing is just adding columns. So your data types is irrespective, it doesn't matter.
Can you join numbered column to varchar? Relationship.
When you're specifying the relationship,
That is what is the major step here that you are doing.
so if you just want to merge two tables, you said you could do that, cross join, which is give me redundant values.
It doesn't really matter if you do cross join or not.
I just want to merge two tables. I want information in table 1 and table 2. I don't want to specify any condition. All I want to do is just merge two tables.
Cross join.
Just, but want to multiply the values. Like
It will. That's what I'm doing. No, what is your question? Tell me.
No, I don't want the. So all I'm trying to do is.
Okay. What are the matching rows? How many are the number? What are the number of matching rows we have?
14.
Using this query.
Left outer joins of 16.
How many records do we get? Total number of records. What is the left table? How many are left in department table? What are?
Operations and development.
All the matching records in the next table will be null. Now clear? No, right?
So number of records
I know.
will be the same.
Totally confusing this one. What does it display? First is matching records. How many are there?
14.
In department table we have 10, 20, 30, 40 and 50. Do we have 40 and 50 in employee table?
No.
40 and 50 are the rows that are picked from left table. And what are the columns? Department number, D name and location are from left table. All the other columns are from right table. What do we have for right table? Null. That's all you have there. Is that right? So any join that you apply will display matching records. Once it displays matching records, next it will display based on what type of join that you put. If you put left outer join, all the matching records in the left table will be displayed, and the corresponding rows for those those number of rows, whatever have been left out in the right table, will be null. Right? That is left outer join. Any questions in this one? Everybody understood? The next join is right outer join. What do you think it does?
From the right
What is it?
Matching records.
matching records and also the leftover records from the right table and corresponding
Rows in the left table will be null. Right? Yes? Are these two equal?
no.
Yes. Department table is on left side. On right side. Here I am using left outer, here I am using right outer. The output is completely same between these two queries. Understand the concept. When I'm using a left outer join, all the left out rows from the left table will be displayed. When I'm using a right outer join, all the left out rows from the right table will be displayed. So the output from these two queries will be exactly same. Is that right? Yes or no? That is the only difference that you have between left outer and right outer. Everything else works same. So if you're fine with one query, at least one join, can you do the rest? Left or right? If you're good with at least one, just interchange the tables. That works exactly the way right outer join works. Make sense? So what did I say? Inner join, left outer, right outer, and the last one is full outer join. You know what does inner join do? What does outer join, that is left and right, do? What do you think full outer join does? Tell me the correct way. I'm not giving you both sides, right? I'm giving you a nice definition. Tell me what it does, full outer join.
First it displays
Display
the
the
matching
matching
records.
Okay?
Matching records.
Then the non-matching records from the left outer join, left query, as well as the matching
Left table.
Left table, as well as the non-matching records from the right.
So if I run a query, I'm not changing anything with the query, just what I'm changing is keywords. Everything else is exactly same. How many number of rows will we get?
18.
18 is correct or wrong?
Should this be 18?
Matched is 14, left out in left table is 2, left out in right table is 2. So we'll have 18 rows. So these two are the rows that are left out in left table. Corresponding rows are null. These two are the rows that are left in right table, and the corresponding rows in left table are null. Make sense?
Order doesn't matter in this since it just.
Don't worry about the order. You can always sort your order based just by statement. Okay? Is this clear? Any questions? Can you write join? Can you write a join if I give you a couple of tables now and their relationship? If you're able to do it, then we are done with joints. That's all we have in joints. Was it tough? Easy? It'll be easy now. Go back home and open up a couple of tables, then yeah. So you can pull up any column in select statement. You can have any number of tables. So generally, typically what we use is left outer join and inner joins. Make sense? Now I can just show a couple of more stuff in joins. You don't need this, but some people might ask this one. So this is how we wrote left outer and right outer, right? Everything we wrote was using these keywords. But if you want to write left outer join in where clause, make sense? What is my requirement here? Keywords only work there. Whenever I'm specifying a relationship, I put my relationship in where clause, right? That's how we write. Where E dot department number is equal to D dot department number. This is a typical query that we generally write for a matching records, right? If you want to write a inner join, left outer join query, this is also inner join, right? The same data. If you want to write the left outer join, all we have to do is you have to put a plus symbol on the right side table. I know this is complex, you don't need this one, you have to just remember this one. But there were some students who were asking me this about different ways of writing it in where clause. So even if you write it this way, this specifies left outer join. That's because this is the left table, E dot. This is the right table, right? So if I put a plus here on the right side table, this becomes a left outer join. Plus on the right side of the table will do a left outer join. I know it's other way, but that's how it works. So this one will give you all the tables from the rows from the left table. If you want to do a right outer join, all you have to do is put a plus on the left column. So this is another way of writing left outer join. Another way of writing right outer join. There's nothing for full outer, or at least I don't know. Is that clear? Any doubts? So that finishes joins. You have to start practicing this. We are almost done with SQL. I'm left with only one topic, that is subqueries. If I'm done with it, I'm done with SQL.
Will you send us these notes?
Yes, I'm gonna send that.
Because last week I couldn't find some.
Yeah, there's no internet. I cannot copy these files and send it out. So I'm gonna copy it in a pen drive and go back home and change. We have 45 minutes more, right?
Are you going to start surprise?
I can. We have 45 minutes more.
Oh, you gave a question last weekend to solve. Can we discuss that?
What question did I give?
Display all the employees from the employee table who got hired in the first half of the month.
Okay. Does somebody have an answer?
Well, I think.
You have it?
I worked on it. I'm not sure if it's correct. I'm getting the results though. Expected result.
Okay, you don't want subqueries today. That's what you mean.
Yeah, I have an answer for that.
Last day. Yeah. Yeah.
Those are the employees who got hired in first half of the month.
ID click is different,
There might be hundreds of fish.
but I got the same one.
Yeah. There can be hundreds of fish.
Because I did add one structure to the item.
All I need is an answer. How you get it, it's up to you. Still have 45 minutes for subqueries. We'll discuss. We already wasted one day yesterday. Subqueries. So this is a concept where you play with multiple queries in a single query. So when we wrote a query in joins and all other stuff, the way we wrote it is, we had a query or set operators. I can take the example of set operators. We had one query. After that we use a set operator. Another query, right? These are two different queries here, but we are joining two different queries with a set operator, right? But in subqueries, what we do is a query will be inside a query. Okay, when a query is inside a query, that's when we call it a subquery. And there are three places that we could write. That means in three clauses. One is in select clause, from, and where. So these are the three clauses, right, that we use, in which we can write subqueries. So in each type, the subquery is called in a different way. So if I have a subquery in select clause, I call it scalar subquery. If I have written something in from clause, I'll call it inline view subquery. These are types of subqueries. If I have something in where, it's called a subquery. So there are three types of subqueries that we have, and three can be written in select, from, and where. If we have something in select, it's called scalar.
Excuse me.
If we have something in from, we call it inline view. If we have something in where, it's called a subquery. Is this clear? So this is how it is characterized. Now let me come up with some requirements. If you remember, we discussed a case statement. When we discussed case, where is case? We discussed this one, right? What does this do?
Check multiple conditions.
What did this actually do? Case statement? What is it doing? I know it's checking multiple condition.
It's assigning values
For what?
for when you filter it by a particular column.
Associate.
It's displaying for department number 10, accounting, for department number 20, IT, department number 30, research. Right? That is what it is doing. Now, we just talked about a scenario where, let's say if there is a change in the name, if we change it in one table, it can be affected in all other tables, right? When we discussed about joins, that is one of the scenarios that we discussed. So I'll take the same example here, wherein if let's say my query is built like this, okay, and there are hundreds of rows, hundreds of when conditions, let's say for example, and you have to change 50 of them, or 1 or 2 of your names have been changed, and you want to update them. You have to come to this query, you have to change every single time. Is that right? Instead of having hard coding these values here manually, in single quotes you're writing accounting, right? Instead of doing that, if I can pull the name directly from the department table, I can generalize the query. Is that right? I can generalize the query. So keep that example here. If I want to display what is the department name for department number 10, what is the query?
Select the name from where department number
Is this right?
Select the name.
This is right. What did I ask? I want to display department name of what is the department number 10. Is this query correct? Then speak out if it's correct. I've been asking. I'm getting accounting. This is correct. Instead of hard coding it, can I replace this query?
Yes.
Yes or no? We'll give the same value.
Yes.
Yes? When department number 10, then this result. And this one, I'm equating it to department number 10. Right? Can I do the same here? Can I run this? Am I getting all the values correctly? In select statement, I have a select statement. That is a scalar subquery. I have a query
Which is a subquery.
inside a query. Make sense? So whenever you write something in your select statement with a condition, it becomes a scalar subquery. And one rule that you have to remember is always the output of scalar subqueries should be one value. How many values are you getting if I run this? Scalar subquery, it should have only one value. What happens if you get multiple values? Let me open up the employee table or the same query. I'm getting 14 rows, right? For department number 20, it's getting research because we are equating department number 20 is equal to research. Let's say, for example, this query returns two values. For department number 20, let's say we have names, IT and research. Agree? If a general scenario, if this query returns two values, listen to me here. Start copying. I'm gonna give you these notes. What do you do if you copy? So if I have this query, if I run it, if I get two values, you are equating 20 to two values. What should it pick? What I'm saying is scalar subquery should always return one value. If this query returns, when I run this one, it's returning one value, and I'm assigning every time I see department number 10, I'm assigning accounting. Let's say for this, for example, department number 10 returns two values, accounting and IT.
Right.
If I run this query for department number 10, should it display accounting or IT? There is no single way of finding what department should be displayed. You cannot assign one row with multiple values. We are not increasing number of rows because we are not using set operators here. We are using a scalar subquery which is used in select statement. Select statement doesn't increase the number of rows. When you have a result in a select query, that is something like this. When you have a query that you are adding to the select query, it should just add to the existing rows. So if we have 10, it should have only one value that is coming out from this query. Only then it equates. When you have multiple values coming out from these queries, it will always throw an error because scalar subqueries doesn't accept multiple values coming in it. If you have one value, it will assign that value to the row. Okay? For example, I have a requirement here. You guys should tell me this answer. Display all the employees in the EMP table with the highest salaried Okay, display all the employees in employee table and display the highest salary from employee table next to each employee's salary.
So it should compare the first two records.
What is the question? Can somebody explain me? Forget about doing it. Can somebody explain me what?
You want the name against the salary with the order of the highest salary.
So if the max of now,
What does this do?
all this
And display the highest salary from employee table. What is highest salary?
max
Next to each employee's salary. So what does that mean? If an employee has salary 800,
Next to it.
Let's say put the highest.
next to it I need to display the highest salary.
Right.
So I need to add another column with highest salary.
Right.
Tell me. Let's display all the details. There is all 8 columns and a column for salary. What should I do? What is the query to display highest salary?
Select the max salary from
That's it, or group by?
Order by?
what the salary find the highest salary.
That's it. That gives me the highest salary. Next. What am I displaying? All the details from employee table. All the details from employee table still, right? What is my requirement? This one will give you what? Comma. Maximum salary of the employee, highest salary next to every employee's record. You can name it as max L. Is that right? What did I do here? I displayed all the columns, comma, added another column in which I'm getting the maximum salary. That is my requirement. I need to display maximum salary of the employee table next to every employee's record. Am I displaying it? Yes or no?
Yeah. So if you concatenate it, it's like the same column.
What?
If you concatenate sal and max sal, it displays the same.
Yeah, that's not my requirement.
This is a different column.
Yeah.
What if you want to add job and it's divided by job?
What?
What if you want to divide it by job?
Divided by job? What does that mean?
If you want to see that the salesman maximum salary for the salesman and maximum salary for the manager.
Okay.
By job, right?
How many records do you get? this query. Right? What is error that is giving? Single row subquery, scalar subquery. This one is resulting in 5 or 6 records. When I put it in select statement, I should always have only one record coming out of that query. When I'm having 6 records, I'm trying to equate one row with 6 records in this query. Make sense? Are you guys trying to understand what I'm trying to say here? Always the output of this query should be equal to one row. Only then you can put it in select query. If you have multiple values coming out of this query, there is no way that you can equate it to every single row, because scalar subquery doesn't work. How do we do it? We can do it using subqueries. That is the later part, not right now. But using select or scalar subquery, you can only get up to here. Clear? Make sense? Write this down. Come on. So display a table which has 3 columns with the header to be with their headers to be 10, 20 and 30. And the data we have in the columns are the maximum salaries in their respective departments. What does that mean?
And we get a table which has 3 columns, and those 3 columns numbers should be 10, 20 and 30. And the data should be
So 3 columns.
maximum salaries.
number of table.
That's the last thing for today. I'm going to not discuss any other topics. Solve this and you can leave. If you cannot, sit down here until you solve it. Any answers?
Can we have a look at the last SQL statement that you wrote?